Cancer. The mere mention of the word spreads a sense of discomfort to those who hear it. Most of us know someone affected by cancer, a relative, a friend, or even someone in our immediate family. In Sweden alone, nearly 60,000 people are diagnosed with it every year. Many die, but today most are surviving. And this number is growing. In Sweden, scientists are conducting the most advanced research, leading the way on the front lines in the fight against cancer. This is a war against a very difficult opponent. Cancer has been around for as long as man has been roaming the planet. It is a part of our evolution. That's why the front lines of this war occur deep within our cells. And here, all possible approaches must be considered. One successful approach is a research project currently underway in the north of Sweden, in Umeå. The research that Beatrice Melin and her team are conducting is actually detective work.
Den här personen har då haft en annan typ av tumör, men också gått...
Using old church records to identify families for whom cancer has been recurring for generations.
I think the most important way to increase the survival rate is to find the cancer very early or even to prevent it. Because if you find a tumor early, you can make surgery and you will survive.
Cancer is not one disease. It is 200 different diseases. Because there are 200 different cell types in the body. And it's inside our cells that cancer begins. Our body is made up of different organs which are made up of billions of small cells. We have skin cells, for example, and muscle cells and blood cells, each with its essential role in a healthy body. When a cell grows old and dies, a new cell replaces it via cell division, maintaining a perfect balance. But cells can change. They can mutate. When someone gets cancer, what's actually happening is the formation of mutated cells which no longer do their intended job. They begin uninhibited division, overcrowding the normal cells. The cancerous cells soon form a clump, and this we call a tumor. This can cause organs to malfunction and can spread to other parts of the body. Beatrice's team now wants to try to locate the genes that create colon cancer. To date, they have found over 200 families in northern Sweden that show increased incidences of colon cancer. But they haven't found all the families yet. And for those people, it is still unknown that cancer runs in their families. And so it was for Ronnie, when he began to feel bad and at first thought it was because he had too much to do at work.
Jag tänkte att jag var lite uppstressad helt enkelt. Men märkte ju undan för undan att kroppen började säga ifrån. Jag orkade inte riktigt lika mycket. Jag var trött. Och jag började få mer och mer ont i magen.
He was admitted to the hospital where they soon found a tumor in his colon. Ronnie was in shock.
En enorm smärta som man upplevde liksom det här att just i den här fasen när man tror att man själv ska dö. Att inte kunna tänka sig att få se sina barn växa upp. Att inte kunna finnas till hands, att hjälpa eller finnas till.
The treatment, which lasted for 6 months, was effective, and Ronnie's cancer went into remission. But he began to wonder why he got a type of cancer that usually only affects older people, while he was still quite young.
Min mor hade ju också haft tjocktarmscancer. Och min mormor som sagt var också hade haft cancer. Och då börjar man ju tänka liksom att det här verkar som att det går i släkten.
Ronnie's doctor saw to it that he got in touch with Beatrice's team, and they soon discovered that this cancer ran in his family. Now his family is included in Beatrice's research project, looking for genes that may be the cause of this type of cancer. In each cell, we have thousands of genes, assembled in long strings called DNA. Different genes affect the cell in different ways, but much of this is unexplored. Now they want to track down the particular gene that leads to cancer of the intestines.
The goal for the research is to find new genes that explain colorectal cancer in families.
And for Ronnie, who is worried about what these hereditary cancer genes will mean for his children, this research is vital.
Det här är ju en livlina helt enkelt. Det här räddar liv, det de gör.
Tack så mycket.
Ja, men du tar själv.
Bra. Hej.
Ja, men tackar.
Our inherited genes play one important part in this cancer research. But additionally, it is that which determines which genes will be used. Because only a few of all of our thousands of genes are active at any given time. At Uppsala University, they are looking at this more closely.
Hej Annika!
Here at the Rudbeck Laboratory, scientist Linda Holmfeld studies one type of cancer of the blood called acute leukemia.
Acute leukemia is today a very deadly disease. The majority of the patients that are diagnosed with acute leukemia will unfortunately not make it. And we need to find better new treatment alternatives to increase the survival of these patients.
Linda will be looking closely at a cellular function which scientists have recently become more interested in: epigenetics. Simply put, one can say that epigenetics affects which genes in each cell are to be turned on or off. In a healthy cell, the correct genes are turned on. But this can all change if a cell mutates and the wrong genes are activated.
So how many samples are you checking today?
Today we have 6.
Okay. We are interested in studying epigenetics since several different mutations have been identified that are believed to cause changes in the epigenetic patterns in the leukemic cells. And we believe that these epigenetic changes in turn might be involved in the leukemic development, but also in the resistance towards the chemotherapeutic drugs that are used in the treatment of the leukemia.
We can compare epigenetics with the spices in your kitchen, where each seasoning represents a gene in your DNA. For each recipe, only those spices which are appropriate for that dish are chosen. But if you mistakenly use a completely different spice, it would change the dish and could completely ruin it. The same is true in our cells. If the wrong gene is used, the cell can change and become a cancer cell.
If we can identify specific epigenetic changes, this might lead to that we also can identify specific drug targets that can be used in the treatment of leukemia. That sounds really good. Very good news. Yeah, no, it will be interesting to see if it's working. Sounds really good. Thank you.
Epigenetics is an important part of building a complete picture of the cancer cell. How different elements work together as cancer develops. Everything does not always work like we had originally thought. The research can surprise us. Recently, one of these unexpected discoveries was made in Gothenburg.
tittar jag bort dit, vad fan. Jag vill förklara för alla.
Martin Bergös studies lung cancer and skin cancer, among other things. Like Linda, the scope of his research is broad, including everything from the cancer cell's development to better medication.
And this one is even better. I haven't seen this either, have I?
Today I got this first one.
This result is fantastic.
But never before has he experienced such an uproar like that which his recent research has brought about.
Well, I'm not exactly used to receiving hate mail or nasty articles being written about me. I'm also not used to having another scientist scream at me because they're so upset about our results. But actually, if you take a step back, it just shows that the research we're doing is important. And it more or less triggers us to keep researching this and understanding more of it.
What was it that Martin discovered that made people so upset? It began as a routine project in which he was to look at the proteins in lung cancer cells. But when one starts researching, one never really knows where it will lead. And Martin's team is continuously trying to be open to unexpected discoveries. He calls it curiosity-driven research.
When you're studying something, for example, in lung cancer, and you discover something that you haven't planned, it's very often that this unplanned result is more important or more interesting than the first thing that you study.
And that's what happened to Martin. While he was studying the proteins, he made a sensational discovery in a control group with a substance believed to protect against cancer. Antioxidants. Antioxidants are found in varying amounts in the food we eat. High values are found in foods such as broccoli and blueberries. It's now a popular dietary supplement, and there are many products on the market with antioxidants in pill form. One common antioxidant is vitamin E, for example. What antioxidants actually do for our bodies is protect the cells from something called free radicals. Free radicals are a type of aggressive molecule that can be harmful for cells and can lead to cancer. Antioxidants neutralize these aggressive molecules, and therefore it was believed that they protected us from cancer. But Martin Bergös' research now shows that antioxidants not only protect normal cells, they also protect cancer cells. And these antioxidants can therefore make existing cancerous tumors grow even more.
So this is a very thin section of a lung. And here we have a lung tumor. Well, this first result was very surprising, that the tumors increased both in size and in number 2 to 3-fold. That was very surprising. But what is more important in that context is that antioxidants as supplements are widely used all over the world as a strategy to protect yourself from cancer. So it seemed to me very important to find out, is this really a good idea?
This was an unexpected finding, and Martin's team immediately wanted to take it further. They looked at how antioxidants affect the fastest rising type of cancer in the world today, skin cancer. The result was devastating.
So here we have skin cancer cells from a human who has malignant melanoma. But to these cells, we've added an antioxidant. And we're now going to see how fast the cells can crawl.
Antioxidants caused the cancer cells in the sample on the right to spread even faster, a cancer tumor's most harmful behavior.
But what happens over time is that the tumor can spread, and it can form new tumors. And it can spread throughout the body and make tumors in other parts. And that's what's dangerous.
Martin's findings have taken the whole world by surprise. And there are many he has met who are upset about his research.
Of course, there were some scientists that were very upset. Scientists that have worked their entire career in trying to synthesize or develop more effective antioxidants. The driving force in their research is really to identify a compound that can be used to cure cancer. So it's understandable that they would be upset.
Their research has already led to changes in the dietary advice for patients with cancer. But still more research is needed to learn how both antioxidants and free radicals affect our cells. Cancer research aims to both get a better understanding of the cancer cells and to develop new, better medications. But which medicine should be used on which patient? This can ultimately be a matter of life or death. Here at Radium Hemet at Karolinska Hospital, they have been treating cancer patients for over 100 years. And even today, it is still one of the major centers for cancer treatment in Sweden. It's here where physician and researcher Jonas Berg is at work.
Nu får vi skynda oss, för det var iskallt när jag gick sist alltså.
He is struggling with one of the major issues with cancer. Why a drug that works well on one patient may have no effect on the next. Although his current research takes a lot of his time, he still feels it's important to continue meeting with patients.
Are you happy with that?
The clinical work as a physician is highly important for me because every individual, every patient is really unique. It's like a hugely complex jigsaw puzzle where we don't know all the different pieces, but we try to bring together this jigsaw puzzle in an understandable pattern.
Jonas.
Välkommen.
Tack.
Today, he's meeting with his patient Inger. She was diagnosed with breast cancer a few years ago when she was 55. Back then, she didn't believe that she was the type of person who could get cancer.
Jag trodde att det kan bara inte stämma. Jag mådde hur bra som helst. Jag höll på att träna för klassiken. Så hade sprungit Lidingöloppet och skulle göra Vasaloppet. Och jag tänkte, nej, det här kan inte vara sant.
But the results from the tests were clear. There was a tumor in her chest. In addition to surgery and radiation, she received medicines for the cancer. For years, it was believed that her cancer was gone, but now it has returned. In treating cancer, all the cancerous cells must be removed, otherwise they will likely spread again. Today, she's meeting Jonas Berg to talk about a new medicine for her to try.
Och då beslutade vi att vi skulle byta till en annan ny sån här anti-HER2-medicin.
Determining what medication a patient receives is vital but difficult. We increasingly understand that each tumor is unique, just as every person is unique. And there is no one treatment that will work on all cancers. The drug that the doctor chooses can, unfortunately, turn out to be completely ineffective. This is what Jonas is working to solve with his research.
The aim is to better make use of conventional drugs, cancer drugs, to see if they reach their target and if they really bind into the target of the cancer cells.
Once a patient is given a cancer drug, it can take several months before it is known how well it works. And then it can unfortunately be too late. If we could know a drug's effectiveness before the treatment is given, many lives could be saved. So far, this has been an impossible task, but Jonas is now hoping that their research will be the groundwork of a possible solution. They are using a new method called SETSA.
The principle behind this is that you select a set of drugs or a single drug, and then you expose cells ex vivo outside the body for that compound, and then you measure how much of the drug it's really brought into the cell, how much of the drug is bound to the drug target.
To understand how this works, we must look once again into our cells. When given a cancer drug, the goal is that it will bind to the target proteins found in the cancer cell. This is what makes a drug work. But how can we find this out before the treatment? Well, it has been found that when a drug fastens itself to a target protein, the protein becomes more stable. It simply doesn't fall apart as easily. This knowledge can be very useful. A scientist can take a small amount of a cancer tumor, divide it up into many small test tubes, and then treat each one with quantities of different drugs. After this is done, the mixtures are heated up and then cooled quickly. Almost all of the proteins will fall apart as a result, except for the stable proteins that the drug has binded to. Afterwards, they can analyze the samples and determine which drug will work best on that particular tumor. What took months before is now achieved in less than a day. This also means that they can take new samples during the treatment to find out if the cancer cells have developed a resistance. Altogether, this can play a crucial role in the treatment of all types of cancers.
For patients in general, it's of course of major importance that you really have the detailed insight of the cancer biology upfront, aiming at improving strategies for the patient, ideally resulting in a better outcome for the patients.
Soon Inger will start her new medicine, and she knows how important it is to get the right medicine.
Att jag överlever, annars hade inte jag suttit här idag. Och för 15 år sedan så fanns inte de här medicinerna som jag får idag, som gör att man kan leva ett väldigt bra liv trots denna hemska typ av cancer.
The war against cancer is one of the biggest challenges in research today. Because the enemy is a part of our own cells and a part of our very evolution.
It's difficult to defeat cancer because the cancer cells have an ability to find new ways.
Cancer is a complex disease and you really have to, look at it in many different angles.
I think we have pretty good chances to win the war against cancer. The possibility to win the war step by step and small steps together is almost a leap.
It's the only way that we're going to beat cancer. And I think we're going to do it. I think in 100 years, people are not going to die from cancer the way they're doing today, especially not children.
These are the many small steps of progress made by various research projects all over Sweden. Already, most people who get cancer will survive it. The hope is that this disease will be completely defeated.